Hello everyone. So let's start today's Leetcode daily challenge question. So the question is maximum number of points with cost. So you are given an m cross n integer matrix points. Okay. Starting with 0 points, you want to maximize the number of points you can get from the matrix. To gain points, you must pick one cell in each row. Okay, one cell in each row. Picking the cell at coordinates r comma c will add points r and c, okay, to your score. So however, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every two adjacent row, r and r plus 1, okay, picking cells at coordinates r comma c1 and r plus 1 comma c2 will subtract, okay, absolute of c1 minus c2 from your score. Return the maximum number of points you can achieve. So here you can check this example. Okay, so we are given 3 cos 3 matrix. Okay, so here we have to choose one cell from each row. So in this example, here 353 is okay, here it is answer as 353, so these cells are chosen. So what we have to do is we have to maximize points. So these are points which we can collect. So let's say here in this row we have chosen 3. Okay, so in our answer we will add 3. Then if I want to choose this cell, then what I have to do is we have to subtract this value as well, c1 minus c2, so absolute value. So c2 is, this is a third, this is a third column, this is a second column. So 3 minus 2 is 1, so we have to subtract 1 minus this 5. So I'll get 3 plus 4, okay, instead of 5. Now if I choose 3, okay, here we are looking first at the answer, then we will try out different. Okay, so if we see 3, so for 3, okay, for 3, this is the, this is which row, first row, and this is which row, third row, third column and first column. Okay, so 3 minus 1, absolute value is 3 minus 1 is 2. Okay, so not 3 minus 1, 3 minus 2, right? Yeah, here you can see, yeah, it is, wait, okay, so here our answer is 2, but here also, um yeah, right, because this is the third row, but the thing is we are going in for this cell, we are moving from this cell, right, not from first one. So we will check with this. So this is 2 minus 1 is, that means 2 minus 1 is 1. We have to subtract that 1 from this 3. Okay, just now we calculated this 3 minus 1 is 2, but we are not moving from this cell to this cell, right? We are moving from this cell to this and from this to this. Okay, so that is why, so this is the column number 2, this is column number 1, so 2 minus 1 is 1, and we have to subtract that one from our points. Okay, so this is how, what this is the answer, that is 9. So you can see. So if we see mm, other possibilities, if I want to move from 3 to 1, okay, so from 3 to 1, there is no cost which we have to subtract, because it is the same column. Okay, that is c2 minus c1 will be 0. So the answer here it will be 4 till this row. Then from this one to, if I move this one, then again we have to add, so our answer will be total, it's 3 plus 1 plus 1, which is, which is 5. But what we have to return, we have to maximum points, right? So that is why this path is chosen. So we have to explore all the possibilities, and then if maximum of it we will return. So to solve this question, okay, to solve this question, we can see for this one. Okay, if I'm starting from this one, what choices I have to move to this one, 5 and 1. So I have three choices in this example. Again, if I choose this one, I have choice to move to this 3, 1 and 1. And if I choose this, then I have choices of 3. So we can use recursion, but it will make our solution as complex because we have many choices. This is a simple example, 3 cos 3. Okay, but if it is a large example, okay, which is a large value or maximum value, then in that case it will this solution will not be good. So here the question is related to maximizing the points. Okay, so we can use here dynamic programming. Okay, so how we will solve this question using DP is, okay, let's say we are finding maximum points at this row in all columns. Let's say at the end I'm coming to this column, right? This column at this cell in this column, right? So I can come in this column at this row, at the end row I can come at this. So let's say this example, 1 plus 1 plus 3 is 5. So this is 5. I can come 3 plus if in this example it was 9. So 5 and 9, which is maximum 9. So if we place 9 here, then this cell, okay, for last row, okay, our last row will check, okay, we will store the maximum points which we can get at I mean this till this row and this column. Okay, so my end is in this column for this solution. Also this, if I go from 2 5 3, then we have to store this value. Then 3 5 3 3 1 3 also. Okay, so these are possibilities for this cell in the last row second column. We can have 1 1 1 2 5 1 1 5 1 3 5 1 3 1 1. Okay, so in this way, um, we can find the maximum points in this row and all columns. Okay, okay, so if I see this is the only what matrix we have, let's say only this much. Okay, so what will be our answer? Our answer will be 3, right? As we have to return maximum points to move, because this is the maximum point, we have only one row. So we will consider only one row initially that we have maximum. Then we will check with this. So for this row, okay, for this row, if I want to stay in the same row, okay, okay, let's say this example 5, I can come from 1 to 5 or stay in the same column, that is 2 to 5. Or I can and this is from left. So if I from right, if I see, I can be in the same column, or I can come from right to this, that is from 3 to 5, right? So in that way we have to calculate, and we will calculate from left. So we will consider two passes, that is left to right and right to left. So left to right will be, let's for this example here it is 3 cross 3. So that is why I'm taking the second column example, because the first column I have only choice, that is stay in the current one from left, and from right I have choice that I can come from 2 to 1, I can come from 3 to 1, right? So I have choices. So instead of calculating from 3 to 1, what I can do, for second one I will calculate from here to here and use the same for this, right? Okay, so in that way we need two passes, that is left to right and right to left. So let's say this example, consider this example. Our DP contains this 1 2 3 initially. What we are finding, we are finding maximum points in each column, in each column for that row. So for the first row, the maximum points for all the columns will be this. For the second row, for the second row, okay, index will be 1, right? This is for r is equal to 0. For the second row, what we will see, we are using two passes. Okay, first is left to right and right to left. Okay, and that too for each element. Okay, so I can be in the same column, stay in the same column, that is second column, or for the left to right I can come from previous. Okay, previous left also, that is previous column. Okay, so what we will use the formula is, let's say left, initially I'll use the array left. Okay, so initially let's say left of 0 will be what, our dp of 0, because I'm going from left, so I have only one choice to stay in the same column. Now for left of I, okay, I'll start from 1. Left of I will be, I want a maximum, right? So if I want to move, if let's say this example, if I want to move from left to right, so I what cost we have to add, one extra cost, because we are moving from this column 1 to column 2. Okay, so that cost, so that means we have to maximize. Okay, we have to calculate the maximum of initial left of 0. Okay, or that means I'm coming from here, and dp of I plus I, so that means cost. Okay, so we have to travel this much cost. Okay, to stay in the same column. Okay, now similar way we will start from right. Right will be the last column. Okay, so we have three column in this case, so 3 minus 1 will be 2, 2 as an index, which will be equal to dp of column minus 1, and we have to subtract, because we are starting from here, so already we have consider we have cost that much, we have to reduce that cost. Okay, so what we are going to do is column minus 1. Okay, so this is our first. Okay, so similarly right of I. Okay, here I'll be starting from the right side. Okay, so that is why we have to decrement, here we have added, and here we have to reduce. So I is equal to, this is math dot max of what, right of I plus 1, right of I plus 1. Okay, comma dp of I minus I. We have to reduce the cost. So from here to here, if so we are considering this cost, that horizontally, if I want to go from here to here, I'll add the cost, and from here to here I'll reduce cost. Okay, so now we got our left and right, from left and right. So for this column, okay, for this column I will check which is more, from left or right, and in that case right now we have added our cost, right, to move from one column to another column. To while checking, we have to reduce that cost, so that it will be balanced. Okay, so initially we have added, and at the end we will be reducing it. Okay, so our answer, or let's say we will consider another dp, that is dp1, because now we will move to this row, and then for this row we'll check with this. Okay, we right now we are considering this row. So dp of 1 of I, let's say I, is equal to what, it will be math dot max left of I minus I. Okay, right of I plus I, then plus the current value, that is point, let's say we have our row as r, and this I. Okay, so we'll add this point to the current one. So in that way we'll get our new values. That means for this row, and for each column, what are the maximum points we are getting. Okay, and at the end whatever column we'll get we will return the maximum. So let's say this example, consider this example, that is 1 2 3. This is our initial dp. We have initialized with the first row. Now our left array, okay, left array we want to calculate, and we want to calculate our right array for r is equal to 1. R is equal to 1. Okay, so for to calculate left, so left of 0 is dp of 0, that means 1. Left of 1 is left of, okay, here it should be I. Left of I minus 1. Left of 1 will be left of 0 and dp of 0 plus dp of 1 plus 1. Okay, what is left of 0? Left of 0 is 2. Sorry, it is 1. Left of 0 is 1. 1 comma dp of I is right now our 1. So instead, okay, I is right now our 1. We are moving from left to right, right? So I is equal to 1 to column minus 1. Okay, so I is equal to 1. So dp of 1 plus I is 1. So 3. So 3 comma 1. So maximum is 3. Okay, so similarly for I is equal to 2, uh, okay, 2 minus 1 is 1, left of 1 is 3. 3 comma this 3 plus 2 is 5. So 3 and 5, what is maximum? 5. So now we got our left as this. Okay, now we want to calculate right. So initially it will be, so okay, this is, we are moving from I is equal to column minus 2, okay, to 0. Okay, initially the last element will be what? Last, this 3. Now comma, for this one, okay, for this one, right of I plus 1, that means this 3. 3 comma d of I is 3 minus 2, that is 1. So 1 comma 3 is 3. Okay, we have okay. So what was our right plus I plus 1? I was our column minus 2. So plus 1 will be column plus 1. So that means the value 3. 3 comma d of I is column minus 1. So d of our dp. Okay, this is dp. So dp of I is this 3 minus I. Our I is 2. Okay, so I is 2. So 3 minus 2 is 1. So 1 and 3, which is maximum? 3. Right? Again, for the first element. Now, this 3, comma, dp of I is 2. Um, just a second. dp of I is 1, right? Yes, let me check if I did anything wrong. Okay, so here for this element, I is what? I is column minus 2. So column minus 2, column 3, 3 minus 2 is 1. Okay, so dp of 1 is this 2. So this is 2 minus 1, 1. So out of 1 and 3, which is maximum? It is 3 only. Now for this case, right of I plus 1 is 3, but dp of I is 1. 1 minus 0 is 1. So here we will get 3. Okay. Now we want our new dp. New dp. Okay, new dp is what? From left we will subtract that I. Okay. So 1 minus 0 is 1. 3 minus 0 is 3. So what is maximum? 3 plus the current value, that is 1, comma this maximum of this 2 is 3 minus. Okay, wait. Here we have to add. Here we have to add the value 3 plus 1. Okay, so 3 plus 1 and 1 minus 3 plus 0 and 1 minus 0 is here, it is 3. Now 3 plus 1 and 3 minus 1. So the value is maximum is 4. Again 3 plus 1 is 4 and here it will be 4. And now here we have to add what? Add the current value is 1. The current value is 5 and the current value is 1. So we got 4, 9 and 5. This is our new DP. Okay, so I think we have made some mistake in right, that is DP of column minus 1. Yeah, we made one mistake because I'm getting here 9, right? So this is not correct because we can clearly see how can we get 9. So the one mistake which we made is while considering the last element. Here we have to subtract, that is why we have to subtract the cost, because we are subtracting in each and we are not have not subtracted this one. So let's calculate this right again. This is the importance of cost. Okay, so column minus 1 is 3, and again what is column? Column is 3. 3 minus 1 is 2. So here it will be 1. Okay, so here you can see dp of column minus 3, 1 is 3 minus column is 3, number of columns are 3 minus 1, which is 3 minus 2, which is 1. So here we'll get 1 first. Okay, now okay, now for the next one, what we have to consider, this right plus 1, that is this 1. Okay, 1 1 comma dp of I is what? Column minus 2, that is 2. So dp of 2 minus 2, dp of 2 is 2 means second element. Okay, so dp of where we are starting column minus 2. So column is 3, 3 minus 2 is 1. So dp of 1 minus 1. What is dp of 1? 2. 2 minus 1, 1. So out of this both, we got our 1. Now, we have again 1, and dp of I, that is this 1 minus 0 is 1. Again we got 1. Okay, now left minus 0 and left right plus 1, right plus 0. Okay, it will, the maximum value is 1. Again here left minus 1 is 2, 2 and this 2, we got 2. And here left minus 1, that is 5 minus 1 is 4, and this is plus sorry, 5 minus 2 is 3. Okay, and 1 plus 2 is 3. So we got here as our answer is 3. Okay, so the maximum, so the values are 2, here it is 7, and here it is 4. So you can see maximum points which we can get in each column and the current row. Okay, so if I move in the same column, let's say I'm considering this one, and one moving here, it is 2. If I consider this 2 to 1, it will be 2. Okay, plus 1 minus 1. Again I will get 2 because the cost. Okay, we have to subtract. Again here 3 plus 1 is 4, 4 minus again 2 because difference is 2. So it is 2. So the value maximum points is 2. So here the maximum points will be 3 plus 5 is 8, 8 minus 1 because the distance is 1. So 7. if I stay in the same row, 5 plus 7, 5 plus 2 is 7. Okay, if I come from here, 1 plus 5 is 6, 6 minus 1 is 5, but we want maximum. So in this way we are calculating in each column and the current row what will be the maximum points which we will get. Okay, so we now we have seen for the first row. Now similarly for the second row, for the third row, we can do, and we'll get the answer. So let's implement it using Java, and let's start coding. Okay. Yeah, let just yeah, so let's start coding. Okay, so let's take one array. Int dp is equal to new int. What will be the size? So let's first take column and row. Int row is equal to points dot length. Int column is equal to points of 0 dot length. Okay. Now dp is equal to, it will be what, it is storing this, so that means it will need column. Okay. Now let's start from, for int, let's take r only, our row. For initially we have to make this, add this value in our dp, right? So from I is equal to 0, I is less than column I plus plus. So dp of I is equal to points of current row, that is first row, and columns. So now we will get our dp of I. That means the first row and all column, that is 0 first and second. Okay. Now we'll traverse from our row. So in r is equal to 1 from 1. Okay, from here, because now we got this our dp. Now we have to update this. R is equal to 1, r less than row, r plus plus. Okay, because we need to do this for all. Now we need what, left array, we need right array, and we need new dp. Okay, to store the maximum points in the current row. Now let's do this for our left. Okay, so left of 0 is what, dp of 0, and right of column minus 1 is equal to, okay, is equal to dp of column minus 1, again subtract column minus 1. Okay, this is important, because while dry run we have seen how our answer get wrong if we don't use this, because we are adjusting the cost rate. So let's, for int I is equal to 1, so I is less than column I plus plus. Now left of I is equal to math dot max of left of I minus 1, comma dp of I plus I. So we are moving rightwards. Okay, from left to right, so we are adding the cost. And for int I is equal to column minus 2, I is greater than or equal to 0, yes, and I minus minus. Okay, we are moving from right, column minus 2 is greater than, yeah. So right of I is equal to math dot max of right of I plus 1. Okay, I plus 1, comma dp of I minus I, because we are moving from right to left, so we need to reduce the cost. Right now we, and at the end, okay, now we got our left and right. Now for maximum points, okay, from I is equal to 0, I is less than column I plus plus, here new dp of I is equal to mat dot max of what, left of I. Okay, as we have added, we will here reduce I. Okay, so that this cost will not affect our answer. And here we will add. Yeah. So here we have reduced added, so that is why we are reducing, and here we have reduced, so we are adding. So we need this, and at the end we have to add our points of what, current row, this current row, and this column, that is I. Okay, so in this way we'll get our new dp. And then um, we have to do this dp is equal to new dp. Okay, so every time we'll create array, and then we'll assign these values whatever we got, this 274, to our dp. Okay, so if we yeah, so now, okay, so this is our for loop which will calculate at each, at, and we don't need, okay, so we don't need what, this. Now if I calculate for the next row, we don't need this. So that is why I'm reassigning this new dp to this dp. Okay, so if we do this for the next also. Okay, so what we have to, let's say we have only two rows. Then what is our answer? Our answer is 7, from 3 to 5, or or we can go from 2 to 5 as well. Okay, so our answer is this. We are not returning what, we are not returning the index or the exact value. We have to return just the sum. Okay, it is not compulsory that we need to return this 2 and 5 or 3 or 5. It may be anything, we just want the cost, right? Okay, so we have to calculate the cost. So what is our return type? Long. Okay, so let's take mm, long answer. Okay, we have to return what, maximum. So let's take integer dot main value. Okay, for int I is equal to 0, I is less than what, column I plus plus. Okay, I plus plus, answer is equal to math dot max answer comma what, dp of I, and return the answer. Okay, so in this way you can solve this question. So let's see once again. What we have done is, first, okay, from row, column, and we need, okay, so here we have return type as long. So instead of integer, let's take long only. Otherwise, if our answer is in the long range, then it will give us error for some test cases. Okay, so here also take long because the value is, okay, everywhere we have used the long, right? So okay, we have we use this, and then we have, or use this the first row as our first initialization for dp. And then, yeah, then we need one left array, we need one right array, one new dp. Then assigning this left first element to the left, and for the right one the last element, and also reducing the cost. And then for the left I, we need a maximum of left of I minus 1 and dp of I and plus I. This is the adjustment cost from moving one row to one column to another. And this is for, we'll, here we need to reduce the cost. Okay, and at the end we are using new dp. Okay, we are assigning the values, maximum points which we are getting. Okay, here we have reduced because initially we have added, and here we are adding because initially we have reduced, because this is the adjusting cost which we don't have to return, right? We have to just calculate the points. Okay, so now assign this dp as new dp. Then, okay, so here we have the long, so let's use this long. Okay, long dot, no, wait, it was long only. Long dot main value. Then from this we will get our answer. Then we'll return our answer. So let's run. So we have used a DP, okay, to solve this question. Let's wait for this to run. You can do for the last row also. Then you'll get the answer as 9. So here for this value from left to right, okay, from left to right we have to calculate. That means stay in the same row. Okay, wait. New long cannot be converted. Okay, here DP. Okay, so yeah, this is the error. Okay, same error everywhere. Yeah, everywhere DP, and here once DP. Let's run now. DP, DP, DP. Okay, DP. No DP. Answer. Okay. Yeah, DP only here also. Mhm. Okay, you can see our solution is accepted. Now let's submit. You can first dry run this like whatever I did here for the next row also, and check, then you will better understand. So here what we initially did mistake is we haven't reduced the cost, because as we are playing with cost, because from left to right, right to left, moving from one column to another column, so we have to consider this, okay, otherwise our answer will not match. Okay, so now we have solved this question. So if you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated. Thank you.